Okay. Thank you. Good afternoon and good morning, everyone. Welcome to the sharing knowledge session. Let me introduce myself. My name is Vidyastuti. I will be serving as your moderator today. And today we have two presenters. The first presenter is Mr. Luis Dijkstra. He is the head of the economic analysis sector of Directorate General for Regional and Urban Policy in the European Commission. And he will present a topic about the degree of urbanization. The second presenter is Mr. Ahmad Fauzi. He is our colleague from the Methodology Directorate, and he will present the progress of our project regarding the implementation of the degree of urbanization. But before we get started, let us hear an opening speech from our director, Bapak Sarpono. Pak Sarpono, the screen is yours.
Okay, thank you. Okay, ladies and gentlemen, good afternoon, and special for Luis, good morning. Thank you very much for your coming in this sharing session. Especially a very big thank for Luis for joining with us today in order to share your knowledge. And Luis, nice to meet you again. We have met twice before at United Nations Expert Group meeting on statistical methodology for delineating city and rural area in New York, January 2019. And the second time we meet at the DEGURBA webinar organized by Indonesia Ministry of National Development Planning on April 2022. And ladies and gentlemen, currently the use of geospatial data for analysis purposes in our organization is limited, even though we have various kinds of geospatial data. Referring to the statistical business process, the utilization of the geospatial data in our organization is still focused on the data collection phase. In fact, geospatial technology is growing very fast. Supposedly, it is an opportunity for us to explore more of the technology for the modernization of our statistical business process. One of them is for data analysis activities. As one mandate by Chief of Statistics Indonesia, Bapak Margo Yuwono, he said that the role of BPS Statistics Indonesia is not only as a data provider, but must able to provide an insight and play a role in development policies. As we know, in the new era of Industrial 4.0, big data is a new source of data, has a big opportunity in providing data faster and cheaper compared with the traditional method of data collection. One of them is we can using geospatial data and remote sensing. And currently, Directorate of Census and Survey Methodology Development, Statistics Indonesia, doing a project that attempts to integrate the population census data and the geospatial data to produce new information. This information is the main data source for calculating some of SDGs indicators that are related to the urban and rural areas. And today I'm very grateful to Mr. Luis, who are able to attend this meeting and share your knowledge with us. We will use the opportunity to get some insight and feedback from you in order to improve the quality of the data that is currently being worked on. I thought it is all I can say this opening speech. Thank you very much for your attention, and I give the screen to Mbak Vidyastuti. Thank you.
Thank you, Bapak Sarpono, for your enlightening speech. I think without further ado, I'd like to welcome our first presenter, Mr. Luis, to start the presentation. Mr. Luis, the screen is yours.
Thank you. just to use our time optimally, the presentation I gave in the previous meeting, did everybody see that, or is it useful if I give a short summary? What?
Actually, we haven't seen the previous slide that you have presented before. You can use that slide. It's okay for us.
Okay. Just to kind of quickly walk you through it, I don't. I'll give a short overview. Let me share my screen. Yes, I can. Here we go. Now you should be able to see it. Could you confirm?
Yes, it's clear.
Okay. So, the goal of this presentation is to give you a brief overview of where of the degree of urbanization and how and why we developed it, right? So this is a UN endorsed methodology to define cities, towns, and rural areas, and especially for international comparison. And it was developed together with the OECD, with the World Bank, UN Habitat, and the ILO, Institute for Labor Organization. Let's see. So this is a quick overview. The reason that we announced in 2016 that we wanted to develop this is because we were aware that the Sustainable Development Goal indicators themselves were harmonized, but the definitions for what is a rural area, what is an urban area, or what is a city was not. And we know and we've measured the impact of those definitions on a number of SDG indicators, be they rural or city, and it has a big impact. So, for example, in some countries, smaller towns are considered rural, and as a result, their access to electricity of the rural population will be better than if those towns were defined as urban. And the same is true for banking, services, mobile network, access to safe drinking water, etc. Also, the city definition, public transport tends to be better in the city center than at the edge of the city. So depending on where you draw that boundary of that city, your numbers may go up or down, which makes it very difficult to compare these numbers across cities within the same country or especially between countries. Also, the change of land, the relative change in population is difficult to compare if you don't have a harmonized definition. Pollution, open space, all these things really depend to a large degree, first of all, on where you put the boundary, and only then can you start comparing. We did compare national definitions, and we really found that there were too different to be compared across countries. Different definitions, they include different indicators, different spatial resolutions, different concepts. So it's really difficult to use the data based on national, urban, and rural definitions to compare those across countries. So we came up with a new definition, degree of urbanization. But before jumping in, let me just briefly explain you why it's difficult to define urban and rural area. This is beautiful little hamlet in Scotland. But if you define urban as just a local authority with a large population, this becomes an urban area because it's part of the local authority of Highland Council, which almost has 250,000 of inhabitants. So just using population size for administrative areas creates a strange classification. This clearly doesn't look very urban, right? But if you use population density, you get other issues. This then, Ulaanbaatar, would become rural because it has a very low population density, even though this capital of Mongolia has 1.4 million inhabitants. The local authority is very large in terms of area, so it has a very low population density. So this problem of big areas, small areas, creates a lot of distortions. And so what we have done is we started with a standardization of the initial spatial unit. We use grid cells of the same size and shape, 1 by 1 kilometer. And so, for example, here you can see two little maps of the Netherlands. On the grid map, these are both population density maps with the same scale. You can see two little settlements side by side. But this settlement is visible when you look at the density of the municipalities, but the other one is not, because it's part of a larger municipality that includes a natural park. So really, you need to have this harmonized grid level at the start to really make a good comparison and identify settlements. I would add that having a population grid is a very useful tool. We use it to calculate travel time to hospitals, to schools, to train stations, exposure to flood risk or forest fires or earthquakes. I think the grid is really becoming an extremely useful tool for a wide range of analysis that you simply can't do with data at administrative or statistical unit levels that have different sizes. Census enumeration areas, for example, tend to differ a lot in size. In Australia, they even differ by more than a factor of 1,000,000 between the smallest and the biggest one. So we have the degree of urbanization. It consists of two levels. First we have level 1, which identifies 3 classes: urban center, urban cluster, and rural at the grid cell level. And then we translate those into the local spatial units into city, town, and semi-dense, and rural. And so on the left-hand side of the slide, you can see the grid level, and you can tell everything consists of little squares. And then we use that to classify the named places that they use in South Africa for the urban-rural classification. How does it work in a little bit more detail? Urban centers are contiguous cells with a density above 1,500 residents per square kilometer, and you need to have at least 50,000 people in those contiguous cells. Urban clusters are contiguous cells with density of 300 inhabitants per square kilometer, a minimum population of 5,000 people in that cluster, and then afterwards we take out the urban centers. And then you have the rural grid cells with a density below 300, and all the other cells which aren't part of an urban cluster or urban center. And so here you can see a land use map of Cork in Ireland. You can see the city center in the middle. You can see the harbor and the river, and you can see some further outlying towns and villages. This is then the population density grid. It's still a little bit messy, but you can see the city clearly in the center. But then we classify it at the grid level. And so clearly you see that urban center, which represents the cities, some fringes of suburban development, and some further outlying towns. Then we classify the spatial local units using where the majority of the population lives. So urban, in principle, equals city plus towns and suburbs or semi-dense, but we encourage everybody to use 3 classes. So use cities separate from towns and semi-dense, and then rural areas, so that you start to get a continuum of urbanization rather than a binary dichotomy. Cities are local units that have the majority of their population in urban centers. Rural areas are local spatial units with the majority of their population in rural grid cells, and then towns and semi-dense are basically the remainder. So this is what you see at grid cell level, and this is how we then classify it. We churn if you look very closely, you see all the boundaries of the local spatial units. They're kind of squiggly, Then we turn those into actual squared boundaries. Then we can easily determine where the majority of their population lives. And then we classify those squared boundaries, and then we turn them back into the regional boundaries, as you can see here. And we've developed tools to make this all very easy and quick to do. Tools you can use for free. One thing I wanted to highlight is that sometimes you'll have a urban center that covers what people would perceive as multiple cities, right? They would see that as 2 cities rather than 1. So as the process of classifying it into cities, you can actually decide to have 1 urban center become 2 separate cities. I'm sorry.
Okay,
Was that a question?
no. There is someone who come in and she forgot to turn off the mic. I'm so sorry.
Okay, no problem. Just making sure I answer questions when I get them. So here, this is Poole and Bournemouth in the UK, and so on the left you can see the dense cells. Then we turn that into an urban center in black. Then we classify all the small spatial units in purple. But then rather than having that be 1 city, we actually turn that into 2 cities, Poole and Bournemouth. Then you have the level 2 degree of urbanization. Here we really want to capture even a further detailed continuum, really the full settlement hierarchy. So we split the towns from the suburban or peri-urban areas, and we wanted to really identify different types of rural areas, from the really concentrated like villages to the more dispersed or very dispersed. And this is important because actually rural areas cover the vast majority of the territory. This was developed by the FAO with a number of pilots in the countries that you can see on the right. And so this is how it works. You start from level 1, which is the top level, and then you go down to level 2, where you have the towns separate from the semi-dense, and then in the rural you have the villages, the dispersed, and the mostly uninhabited or the very dispersed rural areas. And we offer 2 types of terms. I like the short and simple because they're easy for communications and they're kind of intuitive, but this works quite well in English. In some languages, it's not so easy to have a full hierarchy of the settlements. For example, I speak French and Dutch, and the word town is quite difficult to translate into French or Dutch. But we also have longer, more technical and more neutral terms. They're a little harder to communicate, but they have the benefit that they're very precise and they don't conflict necessarily with the terms countries use for their national definitions. So here are a couple of examples. This is a grid cell in Lagos, a very large city in Nigeria. And in this one grid cell, you can see on the left, you have over 20,000 people. Here you have a town in Venezuela, and in that little grid cell there on the left, you have almost 5,000 people. And you can see on the right the little map. It's Chaguaramas, and it really consists only of 2 grid cells, but that's enough to get a town of over 5,000 people. Then this is a village in Myanmar, and you really can see that little cluster of houses with a little over 1,000 people. And so you can see on the right-hand side, those dark green cells are a variety of villages in the countryside there. And this is the classic suburban landscape with the curvy linear roads and the individual houses in a suburb outside Atlanta. And on the right-hand side, you can see the red, which is the city, and then you can see that little blue rectangle, and that's where the suburban areas are. This is a dispersed rural area in Switzerland, so you can see some scattered houses, but the density is very low. Only 92 people live in that entire square kilometer. And then I didn't put in a picture of the mostly uninhabited, but I could have shown you a picture of any forest or field without too many people in it. So what do you need to apply this definition? You don't need very much. You need a population grid, and then you need digital boundaries. So you need the boundaries of your local spatial units that you're going to code. Population grids come in a variety of flavors. You can have an official population grid. A growing number of countries are producing those based on geocoded censuses or geocoded population registers. If you know where everybody lives, you get point data and you just aggregate it up. You can estimate a population grid, And then it's really important to start from the smallest spatial unit for which you have a head count, total population. Typically, these are census enumeration areas. And then you combine that with information about where the people would actually live within those enumeration areas. These could be buildings or built up area or addresses, and you can disaggregate the population that way. There are also a number of open access global population grids available, including World Pop and GHS Pop. So then you want your digital boundaries. This is really difficult for us to access all of them. Not all of them are open, or some of them are copyright. In India, they were actually copyright was owned by a private company, so we had to buy them from there. But it's important to use small units, right? The degree of urbanization is not designed to classify regions or provinces, but really designed to classify local municipalities, local authorities, or census enumeration areas. And of course, you need to have these boundaries accurately mapped and in the right projection and with the right coding and names. So then once you have that, with a little bit of time and effort, you can actually produce this. So for example, Lebanon did this themselves. Kenya's been working on this. Tunisia's been working on this. Depends a little bit on the size of the country. Indonesia's not small, so I can imagine it's a bit more challenging. But it shouldn't take a year to apply this definition. It should be able to do this in a couple of months. Apologies. We also have a grid, a new grid that we've put out just recently during the World Urban Forum, where we have updated our population grid, and there's also a grid there coded by degree of urbanization. So this is a map that based on our previous population grid showing the city of Medan and Binjai. And these are based on population estimates for 2015 from the census data of 2010. But for example, our population disaggregation, you only used 497 populated census units in Indonesia. So those are very large, it's almost 4,000 square kilometers. So to get to a grid of 1 kilometer, you have to increase the resolution by a factor of 4,000. So there's a little bit of a margin of error there. So, but we are happy to help you work or produce a population grid. We have some capacity building as well. We've got online resources and online training program. I know one of you already looked at that training program, and we can provide custom support, remote counseling, etc. These are the tools. So we have something that we call Pop to G, which allows you to take a population layer at, from with varying geography, turn that into a population grid. We have the DUG, which turns that population grid to the settlement grid. And then we have the DU-TUC, which turns that grid into a classification of your local units. So, and this is where you can find information on that training course. Just an example here is Lebanon. They applied this recently, and this is level 2 at the local spatial unit level. I think I'll stop here and answer any questions if you have any.
Okay, thank you, Luis, for the interesting presentation. I think before we move to the question and answer session, let's hear the part for the presentation. Is it okay?
Yes.
Okay. Oji, the screen is yours.
Okay, thank you, Ms. Wida and Mr. Lewis. Here I will present to you about how we implement DEGURBA in Indonesia. So sorry. Okay, is my screen have already shown? Is it clear enough?
Yes, clear.
Okay. Okay, Bismillahirrahmanirrahim. Here we'll present to you about degree of urbanization, especially in the pilot implementation in Indonesia. This pilot have been conducted by the geospatial teamwork from the Directorate of Methodology, Census and Survey from Statistic Indonesia PPS. Okay. As mentioned before from Mr. Sarpono, that our chief, Mr. Marco, have stated that Statistic Indonesia have to change, have to transform into a world-class national statistical office. So therefore, there are 7 direction of change, and one of them is the statistical business process transformation. This is a strategy how BPS to be transformed to become a world-class NSO. And from the strategy, there are 2 main approach. The first one is integrating statistical activities, like integrating several survey into one survey, or even integrating another collecting data. And the last one is the utilizing big data, which from big data we could make another approach to produce the statistical indicator. The big data that we want to utilize, there are several kinds. The first one is mobile phone data. The second one is satellite imagery. The third one is geospatial data. The next one is capture data or scanner base. And the last one is social media. From these 5 data, 2 data have been occupied by our teamwork is about the statistical satellite imagery and then geospatial data. Okay, we will talk to you about what is the geospatial data that have been maintained by Statistic Indonesia. The first one, it is about the enumeration area. The enumeration area have been produced by Statistic Indonesia in 2019 by conducting the updating enumeration area. This provide enumeration area into a local administrative unit, which is area that consists around 100 until 200 people in the one area. And in the next year, in the 2020, we have conducted a population census, which is held in the February until September, and it provide the number, composition, distribution, and even a characteristic of Indonesian population. So from these 2 kind of data, we have already get population data that corresponded with the small area unit. And the last one, in the 20 and 21, we have explored how we could make a land cover classification. This classification have been built using the classification using the Sentinel-2, and we use CatBus classifier. And from this land cover exploration, we have already made several class, and one of them is a built up area. So in this geospatial data that we have the 3 geospatial data have influence or if even have one kind of relation to the DEGURBA. The first one is a small area unit, and the second one is population distribution, and the last one is a built-up area. So we want to implement a degree of urbanization. Why? Because look at the other country, mostly in Europe, there is a DEGURBA that have been implemented in the Europe, and it can be used to publish SDGs indicator. Look at this chart. It is published by the EUROSTAT. We tried this one. This from the Applying the Degree of Urbanization book. It showed that the DEGURBA can be used to publish SDGs indicator in a good way, and it can be compared into a global level. The problem in Indonesia is the first one is SDGs indicator that published in Indonesia should be published using the global harmonized urban rural classification. Why? Because we want to publish the SDGs so it can be compared with other country with same mechanism. And the second one is we have opportunity, we have strength in our data. The first one we get geospatial data like enumeration area with which consists small area unit. And the next one is land cover classification in 2021. And the last one, we get the recent population census data from the 2020. And this implementation is also in line with the 7 change of direction proposed by Statistic Indonesia. Okay, here the mechanism that we try to adapt to implement the degree of urbanization. The first one is we will to put level 1 of degree urbanization classification, which consists of cities or densely populated area. The second one is towns and semi-dense area or intermediate density area. And the last one is rural area or thinly populated area. This is from the population grid, a degree urbanization of for the grid cell, and the last one is DEGURBA for the small spatial units. We adopt this mechanism from this manual book. It is published by the EUROSTAT that have Lewis mentioned before. Okay, the first one, this is about the population grid creation. This is the simplified workflow that stated in the publication book, a methodological manual to define cities, towns, and rural area for international comparison. And we implement the workflow in Indonesia, like this chart. We use enumeration area and then join with the population census. And then we create a population mapping, and the population mapping will try to make the population grid, population density grids. Okay, from the next mechanism, we try to we try to produce the degree of urbanization from the population density grids through this mechanism, and we adopt in this chart. The first one, we use the filtering and clustering by contiguity from the population grid. And the next one, we do iteration and filling gap, and then identification of urban center, which is like the Lewis mentioned, that the urban center have to consist of 50,000 population. And then we do our filtering and clustering by contiguity, and then identification, urban cluster and rural, and we create this one, degree of urbanization by grid cell. And then we try to how implement the grid cell into our local municipality spatial unit, which is a village, to make the small spatial units. Okay. Here we adopt several approach from the manual book into our cases, so it can be adjusted for Indonesia. The first one about the global grid cell. Actually, in the manual book, it stated that use a grid cell 1 kilometer 1 kilometer times 1 kilometer. But it have a limitation because with the different algorithm or even runtime process, the grid cells should not be compiled globally. What this mean? It means that there are several differences when we try to use a grid cell that will produce manually. So we adopt to use S2 cell, which is a global grid cell produced and commonly used by the Google, especially in Google Plus Code. Google have published global grid cell. It's called the S2 cell, and in the level 13, actually, it is a grid cell that have area 1 kilometer times 1 kilometer. So it has been already produced by Google, and it is commonly used, and even it is can be globally comparison. And the next one is how we adopt with our cases. It's about the majority role in determining urban center. As we know that Indonesia is a country with a high amount of island, so it will hard to we just use the majority rule in determining urban center. This case about the limited into 5 until 8 grids surrounding the urban center will be included as urban center. The limitation is it will remove possibility of urban center for the grid in coastal area due to limitation of surrounding neighbor. Look at the picture here. This one is classified as rural from the majority rule, but we try to adopt. How about we use more than half, not hard classification, but we use soft qualification. We use more than half of surrounding neighbor are classified as urban center, then the grid will be decided as neighbor. So it increased the possibility of coastal area to become a urban center. So from this result, we adopt to make this one, because we know that there is high possibility in Indonesia that urban center is located in the coastal area. And we built our algorithm using our Python-based module. We developed this module to calculating from the population grid cell classification, and small administrative unit. Okay, this is the links of the syntax. Yeah, this is our result finding from our study. This is the result in 3 provinces that have high islands. The first one is Bali, the famous Paradise Island, and the second one is Nusa Tenggara Barat and Nusa Tenggara Timur. These 3 provinces we chose because the 3 provinces is focused by the ministry to develop the tourism. So we want to know what is the effect of DEGURBA to be implemented to in the coastal area, even the island area that have a huge impact also for the ministry. So this is the result. This is the population density from the Bali, Nusa Tenggara, and Nusa Tenggara Timur. It looks like that the Bali is an island which have a population density, and in Nusa Tenggara Barat is only located in the capital region, which is here in Mataram, and the Nusa Tenggara Timur is so reverse. Let's look at this. What is the right side? The population is reverse in the island. It's only located in here in the in the Kupang, which capital city of the Nusa Tenggara Timur. From this population density, we try to transform to the grid classification, and here are the result. This is the result of the group grid classification. This is a center, cluster, and rural. The red one represents the center, the yellow one represents the cluster, and the last one represents the rural. From this picture, we know that Bali have a large center area, and as along with I mentioned before that the urban center and area in Nusa Tenggara Barat is also located in the capital area. And in the Nusa Tenggara Timur, the urban center is only located in one area, especially in the Kupang. So it means that urban center is only focused in the capital area, or even the high density population. So how we transform from this grid classification into the small spatial units of village. This is how we have produced. This is Bali, and then this results from Nusa Tenggara Barat, and this one is Nusa Tenggara Timur. So as look at from this picture, as mentioned before, that Bali have large of cities, and the Nusa Tenggara Timur is consists of many rural area. Okay, look at the specific view. We try to compare the population create a degree of urbanization and small spatial unit. We compare in the Bali. So look at from this one, it is the population density. It looks like the mountainous area, the one who have located in the high altimeter and or even in the forest. There is no population here. This one, and the population density is only focused in the here in the what is it, the southern Bali or even the northern Bali, which is a location that attract tourism most. And then this is a degree of urbanization. It looks like that the from population grid to degree of especially in classification, the result is along here is the same, is similar. It looks like the mountainous area here or even forest here will be classified into a rural area due to zero population here. And the last one, it is about the small spatial unit. Here we have most one finding that attract us most. It is here. It is a village in Bali, which become cities because the population is located highly in here. Despite the what is it, the populated area only located in this region, and it has a high, wide area, because the population is high here, it will be transformed to become cities. So our finding is the uninhabitable area like a forest, mountain, or even lake will be classified as rural area due to a zero classification. And the second one is most of villages in Indonesia have wide coverage, like this one. These have a wide area. Therefore, even high dense populated grid or urban center grid will cause the classification in the cities. So because it has a wide area and there is what is it, grid classification, grid that classified as a center, this village will be classified as a cities. Okay. Here we would like to discuss with you, Lewis, especially this four problem. The first one is, do you have any recommendation or advice to our education? And the second one is how we assess our produce, especially after we produce the DEGURBA, how we assess the quality produce product of DEGURBA. And the third one is catching point for urban center is too low. It's like 1,500 inhabitants per kilometer square, which is in Indonesia. It's make the possibility increase to be classified as urban center will escalated. So from our view, it will make the grid in the Indonesia will be more classified as urban center than other classification. And the last one is how we could handling isolated urban center. This is one case in the Nusa Tenggara Timur, which there is a grid that classified as a center, but the surrounding grid is classified as a rural. So how we handle the isolated urban center, we we have to adjust this result, or we just let the publish like this. Think this is enough for me to present what is our work have done, and thank you for the opportunity. I will give the time to Miss Vida.
Okay, thank you, OG, for presentation. Maybe have any comment or feedback?
I would, yeah, fascinating presentation, Fauci. Can I comment now, or is that okay? Yeah, okay.
Okay,
Yes.
yes, you can.
So you guys have made amazing progress. Very impressed. I think one of the key questions is about the spatial data that you've used to disaggregate the population. I saw that it was Sentinel and that you have a classification of built up, but it struck me as a classification which is discrete. You have a number of classes. Whereas if you would take a data source which instead of discrete is more continuous, something that measures the share of land covered by buildings, you would probably get a quite different population grid. I don't know how big your census enumeration areas are, but I think if you used something which said, this goes, this cell is, if your initial information is continuous, so if rather than starting from the 10 or 12 classes that you have, because if you start from 12 classes, you might have, okay, this cell is 100% built up. Whereas if you have a source of information that is continuous, where even the smallest cell is somewhere between a 0 and 100% covered by buildings, you would get a more nuanced classification of your population cells, and you would get a population distribution which is more differentiated, right? Because with the classes, it could be that, a cell that is classified as built up, if you use the continuous information, two cells that are both classified as built up, one might only be 50% covered by buildings, the other one 20 or 80. And so that would create some differences. But I think before you, let's make this a conversation then, just me talking all the time. Maybe you you tell me first, how much does the census illumination areas vary in size? Are they typically very small, or how big are they in rural areas?
It's actually so irregular. For example, in the Bali, the small spatial unit is wide, and in the Java Island, which is our country, like Jakarta, the spatial unit is so what is it? It's small, so it's so different.
So yes, in a city area or an area with very high population, typically the census enumeration areas are very small, which then means that once you aggregate, you're trying to create a grid cell at 1 kilometer, it actually means you have to aggregate census enumeration areas, right? Because they're smaller than your 1 kilometer. In the rural areas, or areas where density is much lower, typically they are bigger than your 1 kilometer goal. And so there you have to disaggregate. And there, I think it could be interesting to use a continuous source of disaggregation. If I can quickly, maybe I can share my screen for a second. I wanted to show you what we have done with our latest release. I'm not saying this is right, huh? Because we've started from much coarser population data, but we have used built-up area, which is continuous. So we used an identification of buildings, which goes from 0 to 100%. And so here, instead of seeing a full band of urban center cells, you get 3 distinct cities. So it looks a little bit different. I can't tell you how much of that is because of the different input in population, because both population and built up area changed. But you may want to consider testing also a population grid using a different input data in terms of built up area. And I think inside Jakarta, of course, it won't make a difference, but in the areas with lower density where your census enumeration areas are bigger, it may make a difference. And this was our estimate for 2020, still based on the previous census, obviously, but it would be worthwhile testing that. Then maybe another question from my side is, what kind of projection are you using for those S2 cells?
Okay, it is what is Mercator global Mercator, which is 3857. It's like a global Mercator that Google produced actually.
And is that an equal area projection?
Yes, you're right. It's equal area projection actually.
Okay, that's great. So then on the modifications, I have to say I really enjoy these interactions with different statistical office because I always learn stuff. I always learn stuff, and I really like the change that you proposed for the majority rule, because indeed, you know, you have so many coastal cities, so many islands. Obviously, taking into account that, you know, sometimes half of the grid cells are in the ocean, it makes much more sense to consider the majority of grid cells. The majority of the grid cells, neighboring grid cells, are urban center. It should be considered an urban center. So I think that's a very good modification. In terms of the population density threshold, this is an important question. Ideally, yeah, I would say the goal for it to compare, um, it, it's difficult to change the density threshold. I mean, it might be worthwhile testing just to kind of see what would happen if you moved it to say 2,000 or 3,000. But of course, if say, you know, if Indonesia uses 3,000 and Malaysia uses 1,500, it's going to be very difficult to compare. I do acknowledge that it's you know, you might end up with a population share in urban centers which is very high, and it may include places that you don't necessarily always think of as being a city. But the risk is that if you really modify the threshold substantially, that we undermine a little bit the comparability. My guess is that by using a different covariate for the population disaggregation into a grid, you may already solve some of the issues, and you will get a grid which is a bit sharper, has a little bit more distinction around the cities, and you will find the population in urban centers drop a little bit. And hopefully you'll also find some of those bigger urban centers splitting out in a couple. Then the last thing I'll say, so you know, you showed how some of those villages have cover a very large area, right? And some of them are quite elongated, and so you have a small urban center at the grid level, and then you classify a very large area as a city. This looks funny on a map. It looks very strange. You look at the map and like, but that's the mountaintop. It can't be part of a city. And this is why I like producing both the grid level and the local spatial unit level. I'll tell you what we use the local spatial unit level for. We use that one for surveys of population. So we use it in our labor force survey, we use it in our statistics on income and living conditions, because from a survey point of view, it doesn't matter that we classified a mountaintop as a city because nobody lives there, right? So in terms of like the distortions from a population survey, the fact that we classify an area as city where nobody lives, it won't affect the outcome. And because many of our surveys are still classified not by geocode, not by location, but by the name or the code of their administrative area, we can't code all our surveys at the grid level. So what we do is, you know, we get administrative data, we get statistical data for these local spatial units, and we want to aggregate them up. And as long as they are about people or economic activities, it makes sense. As soon as you want to produce statistics about land, then of course the local spatial unit level is very strange, because, you know, all of a sudden a certain island would almost entirely be covered by cities and urban centers. And so all your natural and agricultural land would not be in a rural area, which is strange, which is why I think the grid cell level actually works better for statistics about land. Having said that, you know, increasingly we are seeing more surveys being geocoded as well. So, you know, if it's a face-to-face survey, the respondent can often like click and locate, you know, the respondent in space. You know, you get the lat-long coordinates, and then of course you can classify them also at the grid level rather than the local spatial unit level. But often, you know, these local spatial units also have a political role. They have budgets, they have expenditure, and it's very useful to be able to combine data at that kind of decision-making level. So I think it's still very useful to be able to classify local spatial units by degree of urbanization, even though sometimes on a map it looks a little bit odd. And so what Lebanon did is they published both the grid level and the local spatial unit level to try and, you know, overcome this kind of strange effect of the different sizes and shapes of the local spatial units, to say, well, this is the underlying grid level, and we classify based on where people live and not based on, you know, the landscape or the type of land cover. Those are some suggestions from my side. Happy to hear your reactions or answer more questions.
Okay, okay, thank you, Lewis, from the feedback. Actually, there are one question that you haven't answered is about the isolated urban center.
Yeah.
This is so how we assess the result of the isolated urban center, because from the calculation, as we know that it will become urban center is based on calculation, but when we look at the field, it's not to become urban center because it's only surrounded by the rural area. So how you react with this?
No, that's a very good point and a very good question. So what we have, so when we apply the degree of urbanization, especially to an estimated population grid, it's important to build in a round of consultations or get expert judgment or look at these results critically. And I'll give you two examples. So we apply the degree of urbanization in Norway. And Norway is a very mountainous coastal country with like deep fjords. And sometimes they would have a city of 50,000, but because of the geography, the urban center didn't really come out. So we would find, you know, 3 or 4 urban clusters. They would add up to 50,000, but they weren't fully an urban center. So in those cases, the National Statistical Institute say, well, here, you know, we reach a little bit the limits of the method, and we actually think this is a city, so we should classify it as a city. And I think that totally makes sense to especially for cities which are close to that threshold of 50,000 and where the geography may explain a strange result. But also the other direction, if you find a single grid cell where your estimates are 50,000 inhabitants, that's a pretty impressively high population density, right? So what we did when we, together with the team in the Joint Research Center, when we estimated all the cities in the world, we actually went in to check. And sometimes, you know, we would look at satellite, you know, other information to try and see, well, could it be that we've overestimated the population in this cell? And so cells with sky high population density, then you kind of assume, oh, maybe the method generated an artifact here. And this is one of the, you know, the difficulties, especially to identify scattered buildings, especially where there's a lot of tree cover, is quite challenging, and as a result, you may allocate too much population into the little cluster of buildings that you can see more easily on remote sensing, and then fail to disperse the building, to capture the more dispersed buildings. So again, for those, if you have a single cell, 50,000, I would classify those as an urban cluster rather than an urban center, and say, no, here we don't trust the method. Local knowledge suggests that this is far more likely to be a town than a city. But this is especially important for small ones, right? If you find 1 million people living somewhere, well, it's going to be a city, right? So it's really for, especially for these small urban centers where it's likely that the method generates a bit of a bias, then I would just change them into a town rather than to a city, for sure.
Okay, thank you, Lewis, for your feedback. It is so clear for us what will we do the next step for the tackle our issues in the DEGURBA implementation. Okay, maybe another question from our colleague here. Another question.
Maybe anyone want to ask any question? Please raise your hand or typing your question in the chat box. No one? I think it's clear enough.
Okay.
Let's see. Maybe we have to wait for a moment.
Maybe just one quick suggestion from my side. If you want to test a continuous layer, you could test the 2020 building area and building volume layers that have just been released by the GHSL team. And Michele is on the call. He can tell you more about it if you have any questions. And that could be a good way of seeing whether using a different covariate produces a very different result.
Yes, if you want to share another presentation? No?
No, it was just a point for information.
Okay. Oji, do you have any additional
Okay,
question or comment?
maybe additional question from me, Lewis.
Ada.
I will have any question
Boleh
for
kecil
you.
pertanyaannya.
Okay, the first one is we have already put the group and we want to use it for the SDGs publication, let's say something like that, especially in the sensitive area that you have already mentioned, like rural access index or even the land use changes. How we use the the SDGs and the group for the SDGs publication. We just do the calculation and just showing us the data. So or we have to adjust something to make the SDGs publication clear enough, maybe.
I mean, my recommendation would be to report them by the 3 degrees, level 1, and show each of the 3 degrees separately. I think that in of itself with a reference to the manual, but one thing I would recommend, just like Lebanon has done, is to also show the maps online so that people can see both the grid and the local spatial classification, I think it's always good practice to be very transparent about what are the underlying spatial classifications so that people can look and understand what areas these figures refer to. What we typically do is also always try and be very explicit whether we use it at the grid level or at the local spatial unit level. And if both maps are online, people can always see. For land use, sometimes it makes more sense to use the grid level. Sometimes also for statistics about accessibility, where we're calculating share population, we sometimes calculate things at the grid level as well as at the local spatial unit level. It always depends a little bit on, the audience, and typically we can do both. So it's not such an issue, but as long as in the title or in the notes below the graph, you're clear about which spatial level you used, and you include a reference to the classification, that is great. What we also do is for the people who want to reuse the classification, we typically provide a download with tabular name, code of the local spatial unit, and then the classification by degree of urbanization. Because increasingly we see this classification also being used by academics or by private data collectors or surveyors. We have, for example, the Gallup World Poll now uses the degree of urbanization. So that's a way that we facilitate that. Eurostat uses it, and national statistical institutes use it, but we collect our own Eurobarometer through a direct contract with a number of providers, and then we ask them to use these codes to apply that to their microdata as well. So that's just another tip to facilitate the people understanding it and reusing it if they want to.
Okay, thank you, Luis. Actually, here I see that Miss Safa Rosea have want to ask, but she has raised her hand, but I do not this restaurant is does Miss Safa Rosea want to ask something to Mr. Lewis? So we'll wait.
Hello, Mr. Lewis. I'm Safa. Actually, I want to ask something, but it's kind of confused how to interpret to your apa istilahnya ya? Gimana? sorry Ji. Aku tuh mau ngomong. May I speak in Bahasa first? Enggak.
Yes,
Intinya gini, gue tuh mau nanya, saya mau nanya, cuman masalahnya takutnya Mr. Luisnya tuh nggak terlalu paham banget. Oke.
Ditanyain aja Mbak, nanti aku coba translatein deh. Monggo Mbak.
Mr. Luis, I need information from your population density. You make some grid into your spatial, right? And apa namanya? Itu level terendahnya apa sih?
Bisa itu aja Mbak, bahasa Indonesianya, aku coba translatein gitu.
Iya.
Apa gimana?
Cuma pengen tahu aja. Itu panjang soalnya dia tuh levelnya tuh level ketika dia membuat gridnya itu levelnya tuh langsung ke population density di level desanya. Dia punya nggak sih population density di level desa kayak gitu loh?
Oke.
Terus mau nanya lagi, dia itu ketika dia menggrid-grid gitu, dia kan kayak mengamburkan beberapa batasan-batasan wilayah nih, ya kan? Ya kan, dia tuh mainnya tuh di level region, or di level village, or di level district kayak gitu. Aku pengen tahu kayak gitu. Nah, kalau misalnya pas ketika dia membuat gridnya itu meng-cut di antara perbatasan 2 district atau 2 village itu, which one yang mana yang mau diambil sebagai kota atau sebagai desa gitu loh. Aduh, gue ribet banget ngomongnya itu. Membahas
Mbak.
menginterpretasikannya ribet. Sorry.
Oke, Mbak Safa, saya coba ya. Oke, Mr. Lewis, I'm so sorry we have to speak in Bahasa first, and we will try to translate to you.
I apologize for not
Okay.
speaking Indonesian. I mean,
Okay. Here we know that you have already created population density from the GISL data. We want to know what is the source of the population data actually. We know that as a statistical office, we do census by district. Let's say it's a village or an area, and the area will be perhaps will be wide, and it makes the coverage will be more than 1 kilometer to 1 kilometer, or even the population. The grid consists of several boundary of the population or even district. So how to transform from the census data actually from the from the boundary area to become a grid level area in the GISL data. So Mrs. Safa want to know what is the detail from the populated data that's collected from the National Statistics Office, which actually it's not a grid level, to be transformed to the grid level. I think that's the question from Ms. Safa.
okay. I'm very glad I've got Michele on the call here because I will give a brief explanation with my limited understanding, and I hope Michele can jump in to say a bit more. So, basically, what we need to do when we get population data at a census enumeration area is we need to somehow gridify them, right? Because we now have boundaries that have a really funny shape, and how can we turn those into a grid? There are a couple of different ways to do it, but the simplest one is to actually work at a higher resolution or a finer resolution, if you will. Because the difficulty is if you try and transform all your census enumeration areas into grid cells of 1 by 1 kilometer, is you're going to lose some. Some are just going to be too small, right? So all of a sudden you've lost census enumeration areas, and that means you don't know where that population goes. So you can recuperate them by, checking which ones you've missed and then turning them into points, but that's a little bit messy and not so reliable. So a better way of working is actually to take your census enumeration areas, and instead of turning them, gridifying them at 1 by 1 kilometer, you could gridify them at, for example, 100 by 100 meter. If you do 100 by 100 meter grid cells, it's very unlikely that you'll lose your a census enumeration area. I mean, it's still good to check. If you happen to have one that has a funny shape, you might still lose one, and then you have to reattribute that population to the right location. But if you do it at that level, the number of issues you'll encounter should be a lot smaller. And so once you've transformed those boundaries into grid cells of 100 by 100 meter, then you can produce a grid, a population grid at 100 by 100 meter using the covariates. And then to get your 1 kilometer grid, you just aggregate the population up to your 1 kilometer grid. And that's it's a little bit more time consuming, but it's a more reliable method than doing it at 1 kilometer. But Michele, please add and correct all the things that I said that were vague and inaccurate.
Good morning. Yeah, good morning,
Morning,
everyone. Thanks, Luis, for good morning. Thank you for discussing and presenting the method that we use for the production of the grid. I would like to show you one slide that recaps a bit the procedure. So if I understood correctly, you used a land cover dataset to create a population grid via disaggregation. That means you have a population count for a certain area, that is a statistical unit, census unit, enumeration area, or any other polygon. And then you want to create this population grid at 1 kilometer or at final resolution like 100 or 250 meters. So in this series of 6 images, we show you how this is done. So we start on the top left, where we see this territorial unit, an enumeration area outlined in red, with an attribute of 104 people. So this is basically census data. The first step, and we move one step to the right, we rasterize the territorial unit at the resolution of 250 meter or 100 meter. This way, the raster, so the grid cells, is aligned to the census unit. So we transform it in a way that it follows the grid. In the third step, we overlay the built-up surface. And in previous comments, Luis was explaining that at GRC, we produce this built-up layer at 10-meter resolution, which is very detailed, and it allows to understand basically the share of the pixel that is covered by buildings. So it's not, well, it's a binary information at 1 meter, but it's a fraction information at 10 meter. So per each 10 by 10 meter, we know the proportion of that pixel that is covered by buildings, and so at high resolution. So in this case, we overlay the buildings to our rasterized unit, and then we move to the second row on the left, where we basically calculate for each of the 250-meter grid cells the proportion of the total built-up of the unit that is contained in the single cells. So in this case, I don't know if you can see my cursor, but this cell here has 31.6% of the total built-up of the unit, the one next to it about 24%, and so on for the other grid cells. How do we use this information? We basically disaggregate people proportionally to the amount of built-up surface. So basically, we multiply the share by the number of people, and we obtain basically the population count. So the grid cell that contains 31.6% of the built-up will get 33.4 people. The one next to it, 24.5, and so on for the other cells. Once we have this at 250 meter, we need to aggregate the grid to 1 kilometer grid cell resolution in order to apply the degree of urbanization. And basically, we sum all the values per 250 meter in one grid cell of 1 kilometer, and we see this in the sixth image on the bottom right. So we see 1 pixel of 1 kilometer will get 12 people. The one next to it, 80, which is basically the sum of all the pixels at the high resolution, so at the 250 meter, and the one below will get 21 people. So this is the method to disaggregate population proportionally to the amount of built-up surface. We have also another methodology that we can apply in places where we have geocoded census. So we have basically points. We see here that those points represent basically households location, so buildings. Each of the building has a population count assigned, and the population grid in this method of aggregation is basically produced by summing the attributes, so the number of people per point in each of the 1 square kilometer grid cells. Yeah, this is all.
Yeah, let us know if this answered your question, Shafa or Fauci.
Okay, yes, it's already answered our question. So it will be
one last question.
Okay, thank you, Ms. Safa. Could you?
Lewis, I want to ask you when we should when condition we should choose 1 kilometers 1 kilometer grid and 100 meters 100 meter grids. Which condition that we used to make, in which condition we choose the first one and second one? Thank you.
So the end goal is always to produce something at 1 kilometer, but in the production flow, it's better to switch to either 100 meter or 250 meter, just to avoid having too much distortion of the original boundary of your census enumeration area. When you saw that we rasterized it, the finer the resolution, the more closely you can follow the original boundary. And so it really helps, even if especially when the census enumeration areas are small, but even if they are big, you can follow the shape much better at 100 meter than you can at 1 kilometer. And so the risk is otherwise that you'll have population that's in your census enumeration area that's actually lying outside the rasterized version of your census enumeration boundary. So by going for 100 meter, you really reduce the risk substantially that there's a spatial mismatch there between the original boundary and the rasterized boundary.
So the goal is still in 1 kilometer grid, but sometimes we have to cut it in smaller pieces so that it can be accumulated into one grid, aggregated. Okay, thank you.
Okay, thank you, Ms. Safa and Mr. Lewis and Mr. Michele. Okay, there is one question also from my college. It's from Miss Novia Permatasari. It is about we know that the DEGURBA is put using the put up area or put up map with the population. Can we involve another data set like the social economic or even agricultural data like how the fields area or even the agricultural fields or plantation to make the DEGURBA more reliable?
That's a very good question, and it's not the first time we've had this question. UN census recommendations used to, and well, the last one actually still says, please consider the type of work people do, or whether they work in a farm or whether they work in agriculture, and also thinking about the types of land use. We have actually explicitly tried not to do that. And there's two reasons for it. First of all, I think that the difficulty they were trying to solve by adding these additional criteria is that when you classify local spatial units, you get a lot of strange results. Remember the beginning of my presentation with those photos of Ulaanbaatar being rural. That's a strange result, if not a wrong result, right? And so then you can say, well, in Ulaanbaatar, nobody works in agriculture, so maybe it is a city. And you can look at the Highlands in Scotland and go, well, maybe a lot of people farm here, and so maybe it should be rural. But I think those are ways that they try to correct an initial result, which was counterintuitive. What we're trying to do now is understand where people live and understand that in a very neutral way, without any assumptions about the type of activity they are engaged in, and really purely based on the proximity to other people. If we would start to include factors like share of fields or share of agricultural workers, you would actually start changing the criteria away from something which purely looks at the population size of a settlement. Here, the idea is very much that, yes, we will have certain towns that have a lot of people working in agriculture, but maybe their opportunities for diversification, for high value crops is very different than if they lived in a more remote setting or a more lower density setting, right? So the fact that there is agricultural activity, that a lot of people in a town work in agriculture, shouldn't prevent it from being classified as a town, because after all, the town is a certain number of people, and this is also how we start assessing the need for water, electricity, infrastructure, schooling, healthcare. And it would be very strange to say, well, this one is considered to be a medium-sized settlement, but this one has the same number of people, but because more people work on a farm, it's considered to be a small settlement, right? We want to really try and compare like with like. And so when you're measuring access to banking or a mobile phone network, you want to compare settlements of the same population size. And whether they work in industry or services or agriculture shouldn't really affect the classification of that settlement's population size. It can be additional information that you can put on top and maybe distinguish. You know, you can say, well, we can look at towns with a lot of employment in agriculture versus towns with low levels of employment in agriculture and see if they have a different access to mobile networks or banking or what have you. But it shouldn't affect the underlying classification, which is purely based on population density and size. It's a bit of a change in philosophy, and it's a lot of people find it very surprising. I remember I had a big discussion in Tunisia where like, well, that can't be a town. It doesn't have a hospital or it doesn't have an airport. And, well, yeah, but the people are still there. You still have enough people there to justify maybe, you know, a hospital. So in a way, what we're trying to do is turn the question around. You know, instead of having a settlement being defined by what it has in terms of services or economic structure, we're trying to define it purely based on the population, and then to ask the question, well, what is the economic structure? What are the services available? So it really is a change, and it's a good question from that point of view, but it was a deliberate decision not to do that.
Okay, thank you, Mr. Lewis, for the great explanation. So the more we add, the more we will be confused and it will be hard to do. Okay, okay, there's someone who is always her hand is Miss Dia Ikawati. Hello, Miss Dia Ikawati. Okay.
Hello, Oji.
Hello, Miss Dia.
Yes.
So
I would like to ask something. This is my first time learning about degree of urbanization. Maybe my question is a bit silly. I'm sorry for that. I don't really understand actually, but I'm from the demographic division who conduct the population census. So I'm concerned if we use the degree urbanization to do the geospatial analysis for the result of the population census, which is we already produced the data, the result of the 2020 population census classified by urban rural. And it is classified not only by the population density, but also by the social and economic infrastructure, if I'm not mistaken. If we use this degree of urbanization to do the geospatial analysis in the future, will it affect significantly the result that we already published in 2020, and how will how significant is the impact? As if I'm not mistaken, this degree urbanization is the acceleration or aggregation. We do the population density per 1 kilometer, right? And we know that the population density is not equal across the district, and the BPS produce the urban rural classification only up to the district level. So if we accumulate the result per 1 kilometer, so actually, I want to know how until what level you will produce the degree of urban rural classification. Is it up to the village or maybe sub-district or district? Because if we can produce up to the village level, I'm afraid that the result will be different. Maybe the accumulation of all the village will be different with the rural urban classification that already exists in the BPS. Maybe that's all. Hopefully you can understand, Luis and Michele. Thank you.
Okay, now those were a cluster of really good questions. And I'm glad we raised this because these are important, right? And one of the things that comes up often is like, oh, this might be different from our national definition. And that is correct and that's legitimate. And so it's important to flag up the difference between this is what our national definition does and this is what the global harmonized definition does. So that's also why we produced a more neutral term. You talk about densely populated areas, intermediate density areas, and thinly populated areas. If you use that, the conflict with the national definition will be less, just because people from the terminology already will determine, okay, this is different. So I think it's very important to always flag up, is this the national definition or is this the global harmonized degree of urbanization? So from that point of view, important to make that distinction. I actually think it's very interesting to compare the national and the global definition because you learn a lot from that. We've been able to do that for a few countries, but I'd like to do it for more. And one of the interesting things that we see is what happens to the towns in semi-dense areas. In South America, they're typically all classified as urban, and also in North America and Europe. But then in Africa, they're typically classified as rural. And in Asia, it's a little bit of a mix depending on the country you look at. So that's always very interesting to look at. As you're from the demography, let me, we do assume that population density differs within the census enumeration area. So that's why we use these buildings or the built-up areas to simulate the differences in density within the census enumeration areas to generate that grid. Now, when it comes to what level spatial unit to classify, village, sub-district, or district, it's an important question. I encourage countries to use a relatively local level and ideally a level that people can recognize and a level that also has additional information available. So it should be a level that BPS produces data for, or that is used in surveys. So that would be best. That's I don't know whether that should be district or sub-district or a village level. That I leave up to your knowledge. But yeah, often what makes sense is to use the same level as you use for your national definition. If that is, typically where you aggregate data because you have more detailed information, that's what I would suggest. What we have also started doing with the countries that are applying the degree of urbanization is, on the one hand, like Fauci mentioned, produce SDG indicators, but we're also very interested in looking at demographic indicators, population by age and sex. It is fascinating to see how much differences we find between the cities and the rural areas, and it's really worthwhile looking at that because you have different patterns in terms of fertility and migration, et cetera, and so you find really different patterns there, and it's very useful to look at that. So I talked a lot. I hope I answered your question.
Thank you, Luis.
Okay, anyone want to ask a question? Okay, maybe the last question from. Oh, okay, Safa again.
I won't ask any question.
Yes,
I won't
please,
ask
Safa.
any question. I'm just want to say my opinion for Mr. Luis and Mr. Michele that I think it is a challenge for BPS to provide statistics according to global standards using a degree of urbanization. Our village classification, area classification are possible for our data in Indonesia, but somehow, in order to keep the comparability comparability to other countries, somehow we have to produce the statistic according to global standard using a degree of urbanizations so that the data can be comparable, right? So it is a challenge for us to how should in the future it is a challenge for us to disseminate our data into a new level of uh, new level of apa namanya istilahnya new level of this urban rural, not only by urban rural classification but also by using a degree of urbanization. I think itu challenge buat kita ya Mbak ya di methodology. It is a challenge for us in methodology. Thank you.
Maybe a quick reaction from my side. So I think that there are two big benefits from using the degree of urbanization. And the first one is really that international comparison. But the second one is also the continuum. When you move away from a pure dichotomy of either entirely urban or entirely rural, you start to seeing that there are gradations and that there's variation, and that a town is not a rural area, but it's also not like a city. So I think that is really an important incentive. I understand, of course, it's challenging to produce this for a new classification, and doing that in parallel to the national classification is, of course, more work. But I do think it's really beneficial. And maybe the last thing I'll share with you is a comment really emphasized very strongly by FAO. So FAO works on agricultural statistics and rural. And one of the things they were very worried about is that when countries use socioeconomic characteristics, they typically consider things like income or poverty levels to identify rural areas. And so that, in a way, it meant that by definition, rural areas were poor. So if a policy in a country worked hard to make rural areas less poor, they would become urban because they're not poor anymore. And so because you include a consideration of income or poverty in your rural definition, it becomes much harder to actually monitor the changes in those rural areas because you're get an interaction between the definition and what you're trying to measure and monitor over time. So for them, their strong recommendation is keep income and poverty outside your definition of rural so that you can monitor rural incomes and rural poverty. And that really, again, it's a different perspective, but all of a sudden it allows you to have rich rural areas, because they, by definition, they weren't allowed to be rich before. So it's a different way of thinking of it, but it's an optimistic one.
Okay. Gimana siapa? How? Apa?
Clearly enough.
Okay, clear enough? Okay, thank you. Maybe one last question from me. I want to ask about the quality assessment. Maybe do you have any tools or methodology to do the quality assessment of degree of urbanization? That's all my question.
That is a good question. I guess the important thing to do, first of all, would be to really provide very detailed information about all the input data used, right? So that people know the census enumeration areas, their size, the covariates that you use, their spatial resolution, their reference year, whether it's discrete or whether it's continuous, so that that is all very clear. To do a validation of the estimate or quality assessment of the population grid, the only thing I can think of is somehow taking a random selection of grid cells and seeing if you can ground truth it somehow. If for some places you have detailed information where you might have, I don't know, addresses or geocoded location of households, you could test to see how far, how accurate your estimates of the grid are. What some countries do when they, sometimes some parts of the country have a more detailed census, or they have additional information that allows them to do so. But I don't know the exact data situation in Indonesia, so it's hard for me to say, and that would be quite challenging. But if say for example, if you had the addresses of households, that would help if you geocoded those addresses, and then you could check the population of the grid cells. What sometimes people do, but which I don't recommend, is that then they try and estimate the accuracy of a 1 kilometer grid by trying to test it at, say, 10 kilometer scale or 20 kilometer scale, and there you're testing very different things, so it's a bit difficult to do it in that way. But so trying to find more detailed information for a subset of grid cells to see whether that is correct would be my suggestion. But you might have better ideas or know more about what kind of information you can find.
Okay, thank you for the explanation. Well, I think we have reached the end of the session. There is no question anymore from all the attendees. Thanks to Luis, Michele, and Fauzi for the presentation, and thank you for all the attendees for your active participation. You maybe in the next time, I don't know when, but thank you again, and see you. Goodbye.
Thank you to everybody.
Luis.
Have a good rest of your afternoon.
Yeah. Thank you, Michele.
Actually, can
Yes?
we take a picture before we leave the meeting?
Okay. Sorry. Yeah.
Okay, here,
Everyone,
attendant,
maybe
please
can turn
turn on the camera, please. Okay, this is Susan. Okay, the one. Okay, please. Okay, we still try. Okay, try to capture the screen. Give your best smile. Say cheers. Okay, thank you so much. Okay, it's enough.
Okay, thank you. Can we say goodbye?
Luis. Thank you.
Thank you so
Thank
much.
you, Luis. Thank you, Michele.
Thank you,
Thank you,
Luis.
Thank you.
everyone.
Thank you,
Bye.
Luis.
So much.
Bye.
Thank you, Luis. Thank you, Michele.